Welcome back for Module 6, Lesson 2, where we get to step up our game a little bit. We're going to be solving two-step equations in the form of px plus q equals r. And yes, I know that those numbers and variables and whatnot don't mean squat to you, but it's a type of two-step equation that we're going to be looking at here. According to our textbook, you have a goal to solve two-step equations in the form that we just said, and they say this one's going to take us a while, so let us go ahead and launch the presentation and see what all they have to say. Balloon bouquets are used to celebrate many occasions. When creating your own bouquet arrangement, you need to consider many factors such as the number of balloons and the cost and your budget. Suppose a company charges $2 for each balloon and an arrangement fee, and a $3 delivery fee. If you have $9 to spend on the balloon banquet, then you need to determine how many balloons you can actually buy. In doing this, our talk about it says the equation 2x plus 3 equals 9 can help you determine the number of balloons that you can buy in the arrangement or have in the arrangement. Explain the meaning of the expression 2x plus 3 within the context of the problem. And if you know you only have $9 to spend, how can you solve this problem without using an equation? How do you think you could use an equation that might help you solve the problem? These are some of the things we're going to learn about in this lesson. The inquiry question today says, how can you model problems that involve two operations? And to do this, they're going to talk about Latoya. Latoya plays basketball and tennis. She has 2 basketballs and 3 tennis balls, and the weight that weigh a total of 48 ounces. Each tennis ball weighs 2 ounces. What is the weight on the basketball? Use any problem-solving strategy to solve the problem. Be able, however, to explain the strategy that you use. So let's take a look at what they suggest doing here. They say we could use a bar diagram to help find the weight of the basketball. They're going to draw a bar diagram and be prepared to explain how it works in the situation. Alright, so let's see how they're going to do that. For the bar diagram, they're going to let it load for a second here. Draw the bar, of course, and the entire bar represents everything. It represents your 2 basketballs and it represents the 3 tennis balls. From there, we know some information. We know that the whole bar, everything combined, is 48 ounces, and we know that the tennis balls each weigh 2 ounces. So you have 3 times 2 here. You have 2 times some unknown number here, which we're going to call x, and the 2x plus the 3 times 2 are all going to add up to be 48 ounces. So from there, they could hopefully give us a nice equation that says basically what I just said, where you have the 2x, that's your 2 basketballs, times their weight, plus 3 times 2 is the 6 you see right here, equals 48. The 48 is going to be the entire thing. Now, you all know I'm not a huge fan of the bar diagram for solving these. We also have algebra tiles, and algebra tiles are another really good way to visualize how these things work. This time we've got the 4x minus 2 is equal to 10. They've given us a brand new problem here. So let's take a look at how we would lay this out. You've got 4 x's, 1, 2, 3, and 4, minus 2, 1, 2, is equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's my equation written using algebra tiles. 4x minus 2 is equal to 10. So how are we going to solve this? Well, we're going to have to take and start off by getting rid of these 1's right here to isolate our variable. That means I have to add a 1 to both sides, here and here. And when I do that, these 2 1's go in the trash. Then I'm going to add another 1 to both sides, here and here. And when I do that, these 2 1's go in the trash. Now what's left to do? Well, I'm going to break my x's down into 4 groups, nice and evenly spaced. And then I'm going to start collecting my 1's to match each group. So I have 1, 2, 3, 4, 2, 2, 3, 4, and 3, 2, 3, 4. So what does each x represent? Each x represents 1. Each x represents 3, so x equals 3 is going to be the solution to this problem. Now it's going to be your turn. Use these algebra tiles to set up an equation for 2x plus 1 is equal to 5, and then isolate your variable to find your solution. Go ahead and do that now. Alright, I set up my equation. I've got 2x plus 1 is equal to 5. From here we're going to have to do some inverse operations to make things go away. So I'm going to start off by subtracting 1 from both sides. And when I do that, these two zero out and these two zero out. What am I left with? 2x is equal to 4. So now I'm going to pull that x down so I have two solid groups. 1 and 1, 2 and 2. So what does x equal? X is going to end up equaling 2. Check your answer, and it checks. Now, I should add that you need to be able to show your work doing this. This is one of the things they're expecting you to understand, is how to solve these problems using the algebra tiles. Now, as much fun as it is to work all these things with fraction bars and algebra tiles, sooner or later we're going to have to grow up and start using big kid algebra. And that's where we're at right now. A two-step equation such as 5x plus 3 equals 13 has two different operations paired with a variable, vocab word. In this case, the operations are multiplication and addition. To solve the two-step equation, you're going to be using the order of operations in reverse order. You can expect to see the order of operations on a vocab quiz as well. And let's take a look at their video lesson on how to do this.
A two-step equation contains two operations. To solve a two-step equation, first undo the addition or subtraction. In this example, undo the addition by subtracting 3 from each side of the equation. Next, undo the multiplication or division. In this example, undo the multiplication by dividing each side of the equation by 5. The solution of the equation is x equals 2. The solution. Start with the original equation. Replace the variable with the solution. Then simplify to check whether the sentence is true. If so, the solution is correct.
Now, I think the textbook did a great job explaining how to do that. If we go back to right here,
x equals,
that is, let me get it to stop. That is your supporting work. That's exactly what you need it to look like. They did a beautiful job demonstrating it, and for checking it, they did a beautiful job demonstrating how to check your work as well. So since we got all that handled, I think it's time to move on to example 1. Solve two-step equations. The equation they've given us is going to be 2x plus 3 is equal to 9, and we have two steps. The first step you're going to undo is going to be your addition and subtraction. The second step you're going to undo is going to be your multiplication and division. So what's being added or subtracted from x? Well, that's just going to be your 3 right there. That 3 is adding itself to x, so we're going to make it go away by subtracting 3 on both sides. Draw a line through it to show that you have zeroed out that 3, and what's going to be left? 2x is equal to 6. Now, you don't want to take and just divide by 2 on both sides here. You want to create a whole new line like they did right here. Don't just keep stacking pieces into the problem that don't belong there. So you have to have the 2x equals 6 right here. They undid multiplication and division by dividing 2 on both sides. Once again, you want to put a line through that 2, and when you do, that's going to leave x right here is equal to 6 divided by 2 is 3. So the final answer, if you want to type it in there, is 3, but it's the same thing that they gave us right here. This is showing your work. This is what I must see. If I see anything else on each and every problem of this type on your homework, you will have done it just for fun. Now we're going to move on to extra example 1, where you're going to get to pause the video and solve this problem on your own. And the problem says negative 5 is equal to 4 plus 3x. Go ahead, pause the video and solve this one. Alright, let's take a look at it. First thing we want to undo is addition and subtraction. And what's being added or subtracted? Well, it's this plus 4 right there. It's a positive 4, not because of this, but because of the invisible plus sign in front of it. We're going to make positive 4 go away by subtracting 4. If we do it on the right, we have to do it on the left. These 4's are going to zero each other out, leaving us with 3x on the right hand side is equal to, on the left, signs are the same, find the sum with the sign in front of your larger number going in front of your answer. Now I'm going to bring that down, set them equal to each other. Negative 9 is equal to 3x. I'm going to undo multiplication and division by dividing 3 on both sides. 3 divided by 3 is 1. 1 times x, that's going to equal to x. 9 divided by 3 is 3. And a positive divided by a negative, or negative divided by positive, is going to leave me a negative 3x. Jump back over to the textbook, type in our negative 3 is equal to x, check it, and it checks. This is showing your work. This is what I must see. If I see anything else on each and every problem of your homework, you will of course have done it just for fun. We're going to stop this video here, and when you come back, we're going to get started on part 2, where we're going to look at example 2 on how to solve two-step equations.